Good morning, everyone. Today we're going to start a review on area. So we're moving into surface area, and we're going to talk about nets and surface area, calculating surface area of 3D objects here this week. We're going to start doing that, but what I wanted to start with is just a quick review of area. So today we're going to go through rectangles and triangles, and then possibly the circumference of a circle, which, remember from last year, circumference means the perimeter of a circle, so the outside of a circle. So the first thing that we want to chat about, and this is a review, this isn't new to you, so the idea of what is area. So area is, and make sure that you're filling this in on your own notes, the measurement inside a 2D object, okay? That 2D part is important. So realistically, what I'm doing is I'm measuring all of the space inside of this rectangle, okay? So if you think about it, I have 4 units and I have 7 units, or no, not 7, 6. 6 units. So I could count every single one of these squares. Okay, I could count every single one of these squares. So I could go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, and then 24. Okay, so I have 24 units squared. Okay, that's really important to remember, that all area is always measured in units squared. Okay, square units, units squared, however you want to say it. You really are counting how many individual squares there are inside of that or inside of that rectangle, okay? And that's the same for any shape. You're doing the same for circles, you're doing the same for triangles. When we do triangles and circles, it's a little bit more difficult to be able to count that. That's why we have formulas developed to calculate the area. So when we are calculating the area of a rectangle, okay, it is relatively easy, as we are multiplying the measure of the base by the height. Okay, if you were paying attention when I was counting there, 4 times 6 equals 24, right? So if I multiply 4 times 6, so if I think of area, my formula for area as area equals base times height, okay, then, and this is area of a rectangle. I'm going to put that little notation there. Area of a rectangle equals base times height. Then all I need to do each time I have a rectangle is multiply the measurement of one side by the other side. Okay, so I'm just going to measure one side by the other side. I'd like you to stop it now and just take a minute and do the 3 examples. Don't forget to express your answer in units squared. So if it's centimeters, it's centimeters squared. If it's millimeters squared. If it's meters squared. You can have square feet, you can have square inches, you can have squared anything. But you just want to make sure that you express it in those square units. So take a minute and take a couple minutes and calculate those, and then when you come back, I will do the work real quick just to make sure that you understood it. So we have our 3 squares here, or rectangles. So I'm going to write my formula that I'm using. Area equals base times height. Okay, and it equals, I have 4 centimeters or 10 centimeters, I guess, is my base if you really want to. Okay, and then 4. Remember, the order of the multiplication here doesn't matter. So what I get, that's a relatively easy calculation to make, is 40, and my unit is centimeters squared. For my next one, okay, same formula. Area equals base times height. This time I have 9 times 6. If I do that in my head, that is 54. This time my measure is millimeters squared. And finally, I have, again, same formula. area equals base times height. And I have 8 times 6, which gives me 48, and this time it is meters squared. So, relatively simple, something you've been doing for a long time. You can stop the video now and work on the practice sheets for rectangles for about 10 minutes. All right, now we are going to hop into some triangles, okay? So, to calculate the area of a triangle, we need to compare it to a rectangle. So if I try to divide this rectangle into 2 equal triangles, I can usually do that, right? It may not be perfect, but it is about 2 equal triangles. So when I ask what do you notice, the triangles are the same, right? The triangles are equal. Okay, and this is what we call congruent triangles. So if you draw a diagonal line in the rectangle, you obtain 2 congruent triangles. So congruent means that they're the same, and that means that the area of the 2 congruent triangles will also be the same. So if you think about that for a second, I have a rectangle here that I can find the area for, right? If I look, it's 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so I'm going to use base times height, 9 times 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that's going to give me 99. That's for the rectangle. Now, how do I think about that? If I have 2 triangles that are the same, I could simply divide that by 2 to get, it's going to be 49.5 because it's almost 100. So 49.5, that's going to be my answer to get for the area of one triangle. So really, when you're thinking about that, if the area of a rectangle is equal to the area of 2 congruent triangles, the area of the triangle is equal to half. Oh, it says parallelogram here. Parallelograms and rectangles. Rectangles are parallelograms, so I just forgot to change that word to parallelograms, or to rectangle. So it should be rectangle. So the area of a rectangle. Okay, so what that means is the formula for the area of a triangle, I'm going to do this one in purple, area of a triangle equals base times height, and then we're going to divide it by 2. And it's as simple as that. So you'll multiply the base and the height, and then you'll divide by 2. So what I want you to do is take a minute or 2 and work out all of the triangles, the next 5 triangles. Okay, so hopefully you've had enough time to do that. I'm going to go through them with you. So each time we're going to still write our formula, area equals base times height divided by 2, and my base and my height this time. One thing to remember is that base and height of a triangle are always going to make a perpendicular line like that. So I'm going to go 17 times 9 divided by 2. I don't have a ton of space here. Hopefully you guys were able to do that, but remember, we always want to work downwards. I'm going to put it to the right here, just so that we can see it better. So I get 153. That equals 17 times 9 equals 153 divided by 2. And I'm putting that into my calculator just like you guys probably are or did. So I get 76.5 centimeters squared. Okay. Now in this next one, it's kind of interesting because I can't calculate the base and the height in the interior of the triangle. So remember, back to last year, you probably had some cases where the height was calculated on the outside. It doesn't change anything that we do. We're still going to go base times height divided by 2, 4.2 times 3.1 divided by 2, and I get, let me see, I get 13.02 over 2. I'm going to have to put the answer to the right of that, and I divide that by 2, and I get 6.51, and this time I'm meters squared. Okay, and then we're going to do the same thing with these last 3. They're a little bit simpler. The math's a little bit simpler. Base times height divided by 2, we get 8 times 4 divided by 2. Remember, we always want to put this divide it by 2 part in there. The reason I'm showing you that is so that you don't forget it, right? We want to always just carry those things down. Okay, so 32 divided by 2 gives me 16 centimeters squared. All right, and again, we're going to do our formula. I know it seems repetitive, but remember, I am teaching you the most effective way. I want you to remember these things, right? So 7 times 10 divided by 2 or 7 times 10 gives 70, divided by 2 gives 35, and this time my measure is for 35 millimeters squared. And one final time, base times height divided by 2 equals 4 times 12 divided by 2 equals 48 divided by 2 equals 24 millimeters squared. So it's as simple as that. Now, you have some sheets there, continue working on those, and when you are done of those, you can move on to circumference. Okay, so this part should go relatively quick. Hopefully you remember this from last year. So circles, radius, diameter, and circumference of a circle. So circles are a unique shape with unique characteristics. Okay, all the points around the of a circle are an equal distance from the center of the circle. Okay, so use a ruler to draw a line from the center of the edge to the circle. What is the length of this line? If I remember correctly on the piece of paper, it's going to be something around, I think, 4 centimeters. Don't quote me on that. If it's something different, you guys put what it is in there. But the distance of this line is called, this distance from the center to the edge is called the radius of a circle. Now, you might hear me stumble over it later on. The word in French for radius is rayon, so this is the French word. I'll probably say that a couple times just by mistake. So now what we have to think about is that's called the radius. So now we're going to draw from edge to edge going through the center. Okay, so this represents the longest line in the middle, or bisecting, or yeah, let's say longest line through the middle of the, let's put through the middle of a circle. Okay, through a circle. Okay, so it's the longest line because it passes through the center. If, say, I have the same size circle here as what I had up top with the radius, so this time I'm going to say that it is 8 centimeters. Okay, and this is called the diameter. Okay, very similar in French, diamètre. I may spell it wrong along the way a few times. So what we see is a relationship between the diameter and the radius. Okay, so the radius and the diameter. And what that relationship is that the radius, or the diameter, let's go. The diameter is twice the radius. That's one relationship. Okay, and the radius, on the opposite way, is half the diameter. Okay, so if we consider that r is the radius and d is the diameter, create an expression to calculate each measure. So radius is r equals d divided by 2, since the radius is half of the diameter, and the diameter is equal to twice the radius, so we're going to go 2r. Okay, so just a couple quick examples. We want to find the diameter of a circle. That measures the radius measures 2 centimeters, so I'm going to go d equals 2r, d equals 2 times 2, so I get a diameter of 4 centimeters. And then if I have the radius, or if I want to find the radius, and I have the diameter, I'm going to go r equals d divided by 2, r equals 14 divided by 2, Just raise that up a little bit. R equals 7 centimeters. Okay, so this is just the measurement inside of a circle. We should know this. You should remember this from last year. That's just a little quick review of that. Now comes the fun part. We're going to use that information about radiuses and diameters to calculate the circumference. So the distance around a circle is its circumference, okay? The circumference, write a little bit smaller here, is the same as the perimeter, okay? So it's given a special name because it is a circular. So when we divide circumference by the diameter, the value that we get is a irrational number, okay? And what that means is that it's a number that can't be represented as a fraction, and there isn't any repetition in the decimal number. So when we do this, we get a number that starts with 3.14, okay? And it keeps going. It goes for thousands of digits, okay? So this is a special irrational number. Oops, there's two R's in irrational. Known as, and you may have heard this one before, pi, which is a Greek letter, okay, and is represented by the symbol pi. Okay, it looks something like that. You should take a second and try and find it on your calculators. Okay. So we use that measurement of pi. Okay, so when we divide the circumference by the diameter, we get that measurement of pi. We get 3.14, blah, 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 blah. Remember, pi can go for thousands of digits. There's been people who have calculated it and have never found an end to it or a repetition, okay? So we also know that the diameter is twice the length. We just talked about that, of the radius, okay? So to find the circumference, we're going to use this, 2r. Circumference equals 2 pi r, okay? So we can find the circumference if we know the radius or the diameter. The reason why we use 2 pi r and not just pi diameter, that c equals pi diameter, is because later on we're going to have to find the radius, okay? We're going to have to use the radius with area when we review that. So what you're going to do now is you're going to take a few minutes and you're going to walk through doing those with the teacher that you have there with you, those questions for circumference. Start by either finding the radius or the diameter. So in this one you have to find the radius first, then here you have to find the diameter first, there you have to find the diameter first, and then do the work to find the circumference. When you're done of that, take some time and work on finding the circumference of some of the other shapes or some of the other circles that I gave you. And then our next step in our next class will be working on the area of a circle, and then we'll move on to nets. All right, everybody, have a fantastic day.